Hello everyone. First of all, I would like to give a shout out to my newest members. Thank you Silvia Duarte and Krishna Rao for becoming members and supporting the channel. Members get perks such as shout outs on my videos as well as being able to see the thumbnail before the video premieres. If you have a YouTube channel and you would like to promote it, you can consider becoming a member and receive a shout out. Alright, let's get started. So we have the following problem. Find integer solutions to this equation, 3 over x plus 5 over y equals 4. I know at this point you may want to just go ahead and guess and check your solutions, but we're going to be finding all the integer solutions positive and negative for this equation. So let's get started. I'll start by making a common denominator. So let's go ahead and multiply by y here. So that's going to give me 3y. Maybe I can just use a different color here, like this one. All right, here we go. So 3y plus 5x over xy. So if you go ahead and cross multiply, you're going to get 4xy from here. In other words, we multiplied both sides by xy. You'll get the same results if you do it. So in order to solve this equation for integers, I would like to get everything on the same side, but I will use the right-hand side because that's where I have the product. So it's always better, in my opinion, to have the product first. So I can write it as 4xy minus 5x minus 3y equals 0. Okay, now, what am I going to do for this problem? I think we use this technique in other videos as well, and I'm going to be using Simon. But this is a little bit more advanced than normal Simon. So let's see how that plays out. So I have the 4xy minus 5x. The common factor here is x. But that's not what I'm going to take out. I'd like to have a y inside the parentheses. So I'm going to take out 4x. And this is going to give me y minus. Now, in order to get 4x from 5x, obviously, I need to multiply, or to get 5x from 4x, I need to multiply it by 5 over 4. Makes sense? So when you distribute 4x times 5/4, the 4 is going to cancel out. You're going to end up with negative 5x. And then, of course, the rest is similar. I'm going to take out a negative 3. My goal is to get the same thing inside the parentheses, which means I have to have y minus 5/4. But notice that negative 5/4 is going to be multiplied by 3, and that's going to give you 15/4. In other words, I'm adding 15/4 to both sides of this equation. Now, I can just go ahead and factor it like this. 4x minus 3 multiplied by y minus 5/4 equals 15/4. Now, this may not look very nice to you because of the fractions, but don't worry, we'll handle those in the next step. So since we have the fourths here, we can go ahead and multiply both sides by 4, and that's going to give us a nicer expression. The quantity 4x minus 3 multiplied by 4y minus 5 equals 15. Since we're looking for integer solutions, since x and y are integers, 4x minus 3 and 4y minus 5 are also integers. So we're kind of looking at factors of 15 here. We have two numbers whose product is 15. So let's go ahead and explore those numbers. So I can consider pretty much all the factors of 15, including the negative ones, because we're looking for integer solutions. Let's start with the highest possible value for 4x minus 3. So I can basically say that what if 4x minus 3 equals 15 and 4y minus 5 equals 1? Obviously, from here, we don't get integer solutions because the first one gives you 4x minus 3 equals 15, which means 4x equals 18, but we don't get an integer solution. Same thing applies for y. Even if we got a solution for x, we wouldn't get it for y. It wouldn't work. So 15 and 1 is not going to give us a good solution. How about trying 5 and 3? Now, here's what you're supposed to do. If 4x minus 3 is equal to 5, then you're going to add 3 to both sides and divide by 4. So from here, x equals 2. From the second one, if 4y minus 5 is equal to 3, you're supposed to add 5 and divide by 4, and that's going to give you y equals 2 as well. So from here, we get 2, 2, which is a valid solution to this equation. Okay? Now let's try another value. How about switching the 5 and 3 and using 3 and 5. But notice that if you set 4x minus 3 equal to 3, you're going to get 4x equals 6. That's not going to give you an integer solution. So these solutions, or these pairs are not going to give us any solutions. So next, let's go ahead and test 1 and 15. And you're going to notice that we get from here, the values for x is going to be 1, and the y value is going to be 5. Because if 4x minus 3 is equal to 1, that means 4x is equal to 4, x equals 1, 4y minus 5 equals 15 gives you 4y equals 20, and y equals 5. So we get the ordered pair 1, 5 here. X being the first number and y being the second number. Okay, now we're done with positives because these are the only ways to factor 15 into positive integers. Let's go ahead and use the same numbers with negatives. So obviously we do need two negative factors here, like negative 15 and negative 1. If 4x minus 3 is equal to negative 15, you can just go ahead and add 3 to both sides, and that's going to give you 4x equals negative 12, and that's going to give you x equals negative 3. If you set 4y minus 5 equal to negative 1 and add 5 to both sides, you get 4y equals 4, which means y equals 1. So we got that solution from negative 15 and negative 1. If you use negative 5 and negative 3, you're not going to get integer solutions, because if you add 3 to both sides, you're going to get 4x equals negative 2, and that doesn't give you any integers. Next, we're going to test negative 3 and negative 5. If 4x minus 3 is equal to negative 3, that means x is equal to 0. That's a valid solution because 0 is an integer. If 4y minus 5 is equal to negative 5, that means y is equal to 0. And that seems to be a valid solution. Guess what? X and y cannot be 0 because they are the denominators here. Therefore, we're going to reject the solution. Even though it looks like it is a solution of this equation, it's not a solution of the original one, because we made a common denominator, we got rid of all the fractions. That's why we got extraneous solutions. So this is not going to count either. So far we got 3 solutions. Are there any others? Let's go ahead and check it out. What happens if I use negative 1 with negative 15? That means 4x minus 3 is equal to negative 1, but if you add 3 to both sides, you get 4x equals 2. Again, that's not going to give you any integer solutions. Therefore, we end up with 3 integer solutions. Let's go ahead and write those together, and I'll show you how they work, but let's go ahead and write the solution set first. So my solution set is going to be made up of the following. 2, 2 is going to be a solution, 1, 5 is going to be a solution, and negative 3, 1 is going to be another solution. So if you go ahead and remember what the original problem was, 3 over x plus 5 over y is equal to 4. So you can kind of go ahead and substitute these values. For example, if x and y are both 2, then you get 3 halves plus 5 halves, which is 8 halves, which is equal to 4. So you're going to notice that these values actually satisfy the system. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.